Well, hello. We're going to work on Chapter 8, the section on activity today. And the very first step in doing activity coefficients and calculations involving the use of activity is calculating the ionic strength. And so that's goes by the symbol mu for ionic strength. The units are molarity, and it is 1/2 of the summation of concentration of species I times the charge squared for species I through all of the species. Positive and negative ions are counted just the same, and well, that's all you need to know about that. And it's all additive. So I've got two different salts in here, zinc chloride and sodium chromate. And so basically all we have to do is plug it all in. So 1/2. So I've got 0.1210 molar zinc chloride and zinc, and that is 2 squared plus, now with the chloride, for every zinc we have 2 chlorides, so it's 0.2420 molar times -1 squared plus, now we got 0.0325 molar of our sodium chromate. That means twice that in sodium, so 0.0650 molar times +1 squared plus finally 0.0325 molar in the chromate times -2, and you see it's squared, so they come out just the same. So if you plug all that in together, once again, every positive and negative count the same, and they're additive. Everything that's in the solution contributes to the ionic strength, and that all ends up being 0.4605 molar. One other thing I'll say before I end this short video, we're assuming complete dissociation, and especially with multivalent ions, that really isn't often true, but we're going to assume it in any case. So I'm going to stop this one here, and we'll continue with the next step. So that's pretty straightforward. And also, one final thing, you can crank through this calculation each and every time, but it's always the same, whether if it's a 1-to-1 salt, a 2-to-1 salt, a 2-to-2 salt, or a 3-to-1 or 1-to-3 salt. And so you can just memorize what it is, because it's always the same for a given ratio of cation to anion. But anyway, that's how you do that little step.